74.
Yep.
All right. This is part 2, the sequel.
Yes.
This is going to be about word problems.
Mm-hmm.
Okay, we're just going to do 2 examples. And these are word problems that use the rules for expected value and variance.
Right.
And standard deviation. Okay, here we go.
All right. So just here's the rules again. All right. If you want to like take a quick, or if you want to keep moving back and forth while we're doing
Screenshot.
this.
Yeah.
Yeah. And
Or print them out. Actually,
look at them.
if you haven't got a copy in class, we'll give you a copy.
So, all right then. Here's this.
The casino problem.
Yeah. A casino knows that people play slot machines in hopes of hitting the jackpot. Duh. But that most of them lose their dollar. Duh. All right. Suppose a certain machine pays out an average of $0.92 with a standard deviation of $120. Wow. Why would that standard deviation be so large?
I don't know why, Mr. Lewis.
Well, it probably has to do with the fact that the large majority of people are losing.
True.
Because looking at the average, I mean, everyone's losing 8 cents on their dollar, pretty much as you pop it in. So just, they have an incredibly large jackpot, but you know the chances of winning it are so low that it makes the standard deviation big.
True. All right, I was just looking. So I thought the 92 cents was their profit, but their profit's 8 cents, right?
Yes.
So it takes in $1, and on average gives 92 cents back.
Yes.
I get it. So casino makes only 8 cents, Crank?
Yeah, but I mean, it's still not terrible.
Yeah, they do it a lot of times.
I
Okay.
bet they probably actually make more than
Yeah, I get one in my garage.
that. Okay, so anyway, so now we play 5 times. What are the mean and standard deviation of our profit?
Okay.
You know?
All right. So, well, we have 5 identical random variables.
Yes,
So
we
it's like you pull the slot machine 5 times.
Mm-hmm.
So when we would just add the expected profits for each time.
Mm-hmm.
So the expected value would be 0.08, I guess. Or are we going with the 92? Is it?
It says the machine pays out an average of $92. So yeah, I'm thinking the casino's profit off of my dollar is 8 cents.
Okay.
That's
so
how
we'll
I'm
go that
reading
way.
this.
All right. Sounds a little weird wording, but
yeah.
All right. So plus 0.08 5 times. So 5 identical random variables. So expected values add.
Right. Or the faster way would have just been to multiply by 5.
Yeah. So 0.4.
Right.
Now,
so, 40 cents.
The variances
Mm-hmm.
do not, the variances add, not the standard deviations.
Right.
So the thing to realize is we can't just add that 125 times.
Mm.
So we have to add 120 squared to get the variance. So maybe put E of x, or expected value, in front of that. Okay, and then the variance, when we do this 5 times, is going to be 120 squared plus itself 5 times.
So 5 times 120 squared.
Which is 72,000. So variances add. And we're assuming they're independent. One spin on the slot machine doesn't affect the next. Which is probably fair enough. All right. And then, to get the standard deviation, we take the big square root of that.
And?
268.
268. Is that it?
0.3.
Okay.
Okay. Now, so that's just your 5 times. They're going to win on average 40 cents from you. That's their net profit with that standard deviation. Okay, if gamblers play the machine 1,000 times in a day, so this machine gets used a lot, what are the mean and standard deviation of the casino's profit?
Okay then. So, same idea, right? But we're not going to add it 1,000 times. We'll just do the quick.
Right.
Multiply. So
I'm going to say, I'll come back.
E of x is 1,000.
That's 0.08.
Times 0.08.
They would earn $80. That's how much they expect to earn from 1,000 plays.
$80.
Now, you can guess when we add the variance 1,000 times, it's going to be a huge.
Yeah.
So 120 squared times 1,000 was big. It's 14 million.
Am I going to write the whole thing out?
Yep. 400,000. Like that. 14,400,000. All right. take the square root of that, and you get 3,794.7. So, since they're having a lot of people play this game, and they win 8 cents on, even though they only win a little bit on average, it's worth it for them.
Yes.
They can handle the big payouts every now and then.
Yes.
Because on average, they're winning.
Right. So, if they eventually ask you if this casino is going to be profitable, yeah, in the long run, yes.
Okay.
This game would make them money.
All right.
Okay, then.
All right. Now,
cereal.
I don't go to, I've never been to Vegas, so this is a lot more practical problem for me. The cereal question. All right. So, the amount of cereal, you got your cornflakes, Mr. Lewis, that can be poured into a small bowl varies with a mean of 1.5 ounces and a standard deviation of 0.3 ounces. Okay. And a large bowl holds a mean of
Oh, God.
something.
There's a typo.
And then
Always a
0.4
typo.
ounces. You open a new box of cereal, you're going to pull, we'll find it here, one large and one small bowl. All right.
Okay.
So you got 2 bowls here. What chapter are we in?
16, I think.
Yeah, man. We've made it far. Ooh, the cereal problem. The large one holds an average of 2.5 ounces.
2.5. There we go.
Doesn't seem like a lot.
No, doesn't.
All right. How much more cereal do you expect to be in the large bowl?
All right, so this is the difference.
Yeah, so you pour these bowls of cereals, and it varies a little bit from pouring to pouring
Mm-hmm.
how much cereal you'll get. So this is subtraction.
Yes.
Okay, so the expected value,
Of the difference from
let's do
large
L
to
minus S.
small.
Those are our 2 random variables.
Yes.
You just subtract their expected values.
Right. That'd be the same thing as the expected value of the large minus the expected value of the small. So in this case, it would be 2.5
Mm-hmm.
minus 1.5. So just 1 ounce.
Super duper. All right. The standard deviation. Okay, now, we know now that we can't start with standard deviation when we're combining, adding, and subtracting random variables.
No.
We got to start with the variance.
Right.
And variances always add if they're independent.
Mm-hmm.
So we're assuming that when you fill the large bowl, it's independent of how much you fill the small bowl. All right, so the variance of L minus S is the variance of L plus the variance of S. And we were given neither of those, Mr. Lewis.
No.
I think we're screwed.
Well, we could just, square the
All right,
standard
let's do that.
deviations.
Yeah, you're right. We could do that. So that would be 0.3 squared
Yep.
plus 0.4 squared. Why do I have a feeling that's 0.5 squared? This is bringing back memories of the Pythagorean theorem, Mr. Lewis.
Yep.
And you square root that. I do believe it is 0.5. It is 0.5.
Is 0.25,
Oh, 0.25, rather.
and
Yeah.
then
When you
square
take the square
that
root, that gives you the standard deviation.
of 0.5.
So on average, there's going to be a 1.2 ounce difference between the bowls, and the standard deviation of the difference is 0.5 ounces.
Mm-hmm.
All right.
All right, so if
We're skipping C.
we're going to skip C?
Yeah.
Okay.
You know what? We were going to do a different one. We're going to do the total.
Oh.
So let's find out what the total would be. So we want to find out if you add these 2 bowls together, what it would be. This will be easy.
Oh, okay.
Yeah.
So if we did E of L plus 5, or S,
What would be different? This time we would add the expected values.
right. So that would be 2.5 plus 1.5, which would be 4.
Good. Now, the variance is going to be real quick. The reason why is it's the same as above because variances add.
Mm-hmm.
So the variance is still 0.25,
Mm-hmm.
and the standard deviation,
Standard deviation of 0.5.
0.5. Yeah, this was the original question C. We actually threw in part D up there. So this would
Oh.
be if you just combine the bowls. All right, cool.
Okay.
Next. I got it.
And it's their turn.
Yeah, what was the AVA?
The American Veterinary Association.
Of course. Claims that the annual cost of medical care for dogs averages $100. That's not too bad. With a standard deviation of 50. And cats are more expensive?
Yes.
With a standard deviation of
They're
35.
littler. They're smaller. No, smaller tools. I have no idea.
Wow. All right. So we want to know what's the expected difference in the cost of Medicare for dogs and cats. So that's subtraction.
Mm-hmm.
And then the second one, what's the standard deviation? Okay. Remember, variance is add.
Yes.
Third one, suppose a family has a cat and a dog. What would be the expected cost of the care for both pets?
Right.
So that one you would be
Adding.
adding. Very good.
Yep.
It's not as bad as it looks.
No.
Take care.